Hey everybody, it's Mr. Ray here with our next lesson in grade 11 University Math. We are in the Rational Expressions unit, and today's lesson we're going to be looking at simplifying rational expressions. So let's look at what is a rational expression. So a rational expression, by definition, it's a fraction, which means you have a numerator and a denominator. And instead of regular fractions that just have numbers in the numerator denominator, we actually have polynomials. So remember, a polynomial can be, it could be a linear relation like 2x plus 5, it could be quadratic, it could be any kind of polynomial function, any power of x. We're just going to stick with one variable, so you won't see anything with x's and y's usually, but you could have any kind of numerator denominator. You could even have just a constant term in one of the numerators or denominators, and then some kind of polynomial expression on the other side. So there's lots of possibilities for these rational expressions, and what we're going to be doing today is seeing if we can reduce them, seeing if we can simplify them into something that's easier to read, easier to work with. For example, with rational numbers, we get quite used to simplifying and reducing those. If you had a fraction of, say, 5/10, we would reduce that to 1/2. So we're going to use the same concept working with these rational expressions that have variables in them and powers and all sorts of different polynomials. So now, since we can possibly have in the denominator, we could have a value of x that would cause that denominator to turn into 0, and in math that's a big no-no. We can't have divide by 0. So we have something special in special consideration to avoid having that situation. So we have something that's called restrictions. So at some point when we're simplifying our rational expression, we will also, when necessary, include a restriction that said x cannot be a certain value or a certain expression, because if it did have that value, we would have a divide by 0 issue. Okay. Now, we're going to do several examples, but the key thing is always we try to factor as much as we can the numerator and the denominator. And then if we see any common similar factors, both in the numerator and the denominator, we can cancel them out. Okay? It's like having, if we had a 10 on the top multiplying with an x and a 2 on the bottom multiplying with x, we could cancel out. We could reduce the 10 and the 2 to a 5/1, but we could also reduce the x's if we had an x on the top and bottom. So that's what we're going to be doing here. So we always factor first and then cancel out the factors. And then before we cancel out, this is very important, after we factor, but before we cancel common factors, we will state the restrictions. And we'll talk about why we do that as we're doing it. Okay. Now, you can tell based on the way this is going to work, the first thing we always do is factor. Factoring is a crucial skill in this unit. We have to know how to factor polynomial expressions, and not just be able to factor, you have to do it fairly quickly, because some questions you might have several things to factor. Okay, so our first example here is we have a rational expression. We have a numerator that's a cubic. It's got a x to the power of 3 on the top, and we have a linear expression on the bottom of 6x. So we want to simplify that as much as we can. We also want to state any restriction on the variable. Okay, so the first thing I see is, well, I'm going to put an equal sign. So basically every line I write here, will be the same as the one above. I'm not solving for x, I'm just simplifying and making this a little bit smaller if possible. So when we're factoring, remember the first thing we look for is a common factor. And when I look at this expression here, I can see every term in the numerator has an x, and the numerical parts of the terms, I could see I got a 24, a 6, and 12. All of those can be divided by 6. So I actually have a greatest common factor of 6x. So I'm going to put my 6x here. And what's left over when I take that common factor out? So if I divided each of these by 6x, or if I thought to myself, what do I have to multiply 6x by to get 24x cubed? That would be 4x squared. And what would I have to multiply 6x by to get 6x squared? Well, that's just one more x, so plus x. And then what do I have to multiply 6x by to get 12x? That's just a 2. Okay? Now, on the bottom, I have a 6x, and there's not much I can do with that. Okay? I'll just leave it as 6x. It's a single monomial term, so I'll just leave it. Now I'm going to put this common factor in brackets. You don't have to. It's not mathematically essential to do that. But when I start canceling things, it's nice to have everything in brackets if you can. So now when I look at this, I can see I'm going to be I've got a 6x on the top and bottom. So I pretty much know that I'm going to be canceling those. But before I do, I'm going to look at the bottom and see any possible value of x that will make this 0. So for every factor on the bottom, I'm going to see, well, what value of x would make that factor 0. So when you basically start, you're not solving for x, you are, in a way, you're finding what values of x can't we have, are illegal to have. So 6x cannot equal 0. 6x is the only factor here. If 6x was 0, we'd have a big problem. So instead of saying 6x equals 0, like we would if we were trying to solve quadratics in the past or any type of factorable expression, I'm setting this not equal to 0 because this is a restriction. Okay. Now I can divide both sides by 6 and I still get x not equal to 0. So that is my restriction. Now I'm going to go back to the original expression, and at this point I see I can cancel out the 6x and 6x. Now some teachers don't like using that expression cancel. What you really are doing, just to appease that mindset, is I'm dividing the top by 6x and I'm dividing the bottom by 6x. And when I do that, 6x divided by 6x is 1. 6x divided by 6x is 1. And I divide the top and bottom by the same thing, so that's perfectly legal. But most people just look at it as the 6x common on the top and bottom, I can cancel them out. Okay, so once I cancel them out, I'm just left with this 4x squared plus x plus 2 over 1. But since it's over 1, I don't really have to keep it looking like it's a rational expression. I can just make it look like it's quadratic. Okay, and at this point I'm going to put my restriction. So there's my final answer, and I'll put my restriction for x as x cannot equal 0. So those are the two parts of the answer: the simplified version of the rational expression and the restriction that goes along with it. Now, why did we do the restriction before I cancel these? Well, you can see once I cancel these, this is no longer a rational expression. So you might think, well, I guess it doesn't matter what x is. No value of, if I plugged any value of x in here, I'm never going to get a divide by 0 issue. But if you plugged it into here or here, you definitely would. So you have to think about the restrictions before you start canceling things. Otherwise, you're kind of blind to the possible values of x that could cause a divide by 0 issue. So always look up here before you cancel. Okay, so there's our first example of simplifying rational expressions. We have a few more to do. So in the first example, our denominator was a monomial, it's just 6x. So we'll make the denominator more complicated, but the numerator less complicated. Numerator that in this case is a linear, just a single term x, and we have a quadratic in the bottom here. Okay, so the first thing we're going to do here, again, think about factoring. Okay, so the top I can't do really anything, so I'll just leave it as an x. Now again, I'm going to start with common factors. So I can see definitely both terms have an x, and I can divide the 2 and the 4 by 2. So 2x is my common factor, and I'm left with x minus 2 when I factor out the 2x. Okay, so I've done all the factoring I can, and at this point I might be tempted to see what I can cancel, but before I do that, I'm going to look at my possible restrictions. So this time I actually have two factors in the denominator, so I have to look at both possibilities. A value of x that would make this 0, or values of x that would make this 0. Okay, so I've got two things. I got 2x cannot be equal to 0, and I have x minus 2 cannot equal 0. So when I basically solve for x here, what x can't be, divide both sides by 2, still get x cannot equal 0, and here I would get add 2 to both sides, x cannot equal 2. So I've done all my restriction work before I lost what was going on here. Now, you might look at this and say, well, I don't have anything common on the top and bottom. And I definitely don't have an x minus 2 up here, but I have an x on the top and a multiple of x on the bottom. So I could almost think of the 2x as two factors, a 2 and an x. Put the 2 in brackets, the x in brackets, and that might get you thinking in the right line that, okay, I can actually cancel just the x's. The x up here, I'm left with 1, and the x here, if I divide this by x, I would be left with 2. Okay, so what happens when that's all done? Well, on the top, okay, it looks like I canceled everything out, but when I divided this by x, I still have a 1 on the top. And then this factor wasn't completely removed. I still have the 2. And I also have the x minus 2 from that factor, which did not get canceled. And you might think, well, that looks like it's about finished. But let's remember what the word let's think about what the word simplifying means. So simplifying means a couple things. It means, making simpler, but when we looked at it in previous grades, there was two concepts. One was combine like terms, and the other one was get rid of the brackets. So getting rid of the brackets should be part of simplifying. So when I see this, I want everybody to just multiply that out. So you have 2x minus 4 on the bottom. Okay, and these are pretty close to each other, but I think that this is truly simplified where this is partly simplified. Okay, so this is our final answer, our simplified version of this expression, and now we add our restrictions beside it. Now there's two restrictions, x can't be 0 and x can't be 2. You could actually combine those into one statement here. X cannot equal 0, comma 2. So that's basically saying there's two values that x cannot be, because if either of those were used, you get a divide by 0. Okay, so let's keep going. We keep increasing our degree of difficulty here. So now you can see I've got basically a linear expression on the top and the bottom, and they want us to simplify that. So let's look at what we can do. So on the top, if I was looking at how could I reduce, can I factor that at all? Well, there's nothing in common for either term, so I'm just going to leave that. I'll put it in brackets. So it looks more like a factor than just two terms being combined. And then on the bottom, I can see, well, I can't factor an x, but I can factor a 2. So when I factor the 2 out, I get a 2x minus 3. Okay. Now, that's as factors as we can get. So at this point, I can actually do my restrictions. So I've actually got two factors on the bottom. I have a 2 and a 2x minus 3. Well, I don't really need to consider the 2 because the 2 is always going to be a 2. Changing x will not change that from being a 2. And so since it's always a 2, it can never be 0. So I don't have to worry myself about constant factors. I have to worry myself about factors that have variables in, like the 2x minus 3. So the 2x minus 3 cannot equal 0. And then we go about our business simplifying this so I have x by itself. So I'm going to add 3 to both sides. 2x cannot equal 3. And then divide both sides by 2. So I get x cannot be 3 halves. Or you could write this 1.5. Either one would be acceptable. So that's all our restriction work. We're going to add that to our final version of this. Now, when you look at this, okay, this is a kind of an odd one, but it's important. It definitely, these two are not exactly the same, but they have a lot in common. I've got a 2x in both. I've got a 3. So this is a special situation where there's different ways of thinking about this. I'm going to leave my factors on the bottom the way they were, but I'm going to look at the one on the top. Okay, and if I multiplied this factor by -1, I would get -3 plus 2x, or in other words, 2x minus 3. So that would give me the same factor I have in the bottom. Okay, now, but I can't just arbitrarily multiply the top by -1. That changes the value. But what I'm going to do is multiply by -1 twice. So I'll keep this the same, like that, okay? Now everybody should agree that -1 times -1 is 1. So by me multiplying this by 1 has not changed the value of the whole entire expression. But what I can do now is I'm going to take one of these -1s and multiply it with this 3 minus 2x. I still have the first -1. It's not going away, but the second one I'm going to multiply it into these brackets. So I'm going to have -3 plus 2x. -3 plus 2x is the same as 2x minus 3. And now you can see, well, now I have two common factors, top and bottom. 2x minus 3 is for sure the same thing. So I can actually cancel those out completely. I'm left with the 1, but it really doesn't change this. I have -1 times 1 on the top, which is -1, and I have 2 times 1 on the bottom, which is 2. So this actually simplifies to -1/2. And then we add our restriction that x cannot equal 3 halves, which we did the work up here. Okay, so this is kind of an interesting one. We simplified it to the point where there's actually no variables at all, and it's just a constant, okay? Which is kind of interesting because it looks far from that when you see the original version, but it works out that all the factors that have variables cancel. But we cannot forget about those when we do our restrictions, and that's why we look at the restriction before we cancel these. We looked at the 2x minus 3 on the bottom before it disappeared. Okay, so this is a special trick. If you see two factors that look very close, except they're kind of reversed in the position, look at the possibility of doing this technique where you multiply that factor by -1 and then multiply that side of the expression by another -1 so that you offset the original -1. Okay. Okay, now we get into some more. So far, we've only really been doing common factoring, and that's not the extent of our factoring. So let's try something a little more difficult. So I have a trinomial numerator and a denominator, and it's a quadratic. So we want to express this in simplest form, which is another way of saying simplifying this expression. So again, state the restriction. So same process. Now what we're going to do here is we have two factoring to do. We have to factor the trinomial on the top, trinomial on the bottom. We're going to be using simple trinomial factoring. So I know that my factors on the top will be two binomials that start with x, and I also know the same thing on the bottom. And it's just a matter of finding what values go here. So remember, it's looking these two numbers multiplied to -10 and add to 3. Now, the more factoring you do, the more of these you can do in your head. So I'm just going to do this in my head. The two factors of the top are x plus 5 and x minus 2. Now, if you need to do this, and that there's no shame, if you can't do this in your head, what I want you to do is do a little side factoring over here. Okay, do your factoring here and then just move your answer over here. What I don't want to see are people spending 4 or 5 lines in just the factoring process. Okay, I want you to do the factoring separately and just put the result of the factoring here. I don't want to see all the nitty-gritty details of your factoring. If you need to do it, you do it on the like a sidebar over here. This one here, I'm looking for two numbers to multiply to 15, add to 8. Well, I know those are going to be plus 5 and plus 3. Okay, so I've done all the factoring, and you can see pretty clearly that I've got x plus 5 in both numerator and denominator, so I will be canceling them. But before I do that, I want to set the restrictions. So the restrictions, sorry, I'm going to write that at the end. So I look at each of the factors in the denominator and I basically say that can't be 0. So x plus 5 cannot be 0 and x plus 3 cannot be 0, and then just solve for x. So I'm going to subtract 5 for both sides and see that x cannot be -5, x cannot be -3. So I'm going to tack that on as my restriction once I get my final version. And speaking of final version, let's come back here now, and we can see that the x plus 5 factors cancel, left with a little 1 there. So what's left over is x minus 2 over x plus 3. And you can see I kind of saved myself a step here. I didn't want to just put the brackets around and then take them off in the next step, because I knew if I wanted to be simplified, I don't really want to see any brackets. I just want to see terms being added and subtracted. So that's the final version, and the restrictions for x. X cannot be -5 or -3. And it's usually good math form if you have a whole list of values that x can't be, that you put them in ascending order. So in this case, start with the most negative and work your way up to -3. If you didn't do it that way, no big deal, but that's what we try to do, just so if you're looking to find a value, if you have a long list, it's easier to find. Okay, last example here. This time we're working with, again, trinomial numerator denominator, but you can see this time we've got to change a variable. We're using y. No big deal, but the big thing here is we've got coefficients of the y squared. So it looks like it's going to be complex trinomial factoring unless we can factor something out. Okay, so let's check that possibility right now. Can I factor any number out of any constant out of all three on the top? Nope. Can I factor anything out of the bottom? Nope. So I'm left with complex trinomial factoring. Okay, now the top one I know for sure we'll have a 2y at the beginning of one binomial factor and a y at the beginning of the other, and then I can just play around with the 15 for these. It's probably a 5 and a 3, but it could be a 1 and 15, and just looking at the possibilities here using fast factoring. So if this was a 5, I had a 5 there, and that would be a 6, so I have a 5 and a 6, and I want the 6 to be more negative, so that would be y minus 3 and y plus 5, and then just test it out again. 2y squared plus 5y minus 6y gives me the minus y, and negative 15 there, so that works. Now, obviously I did that fairly quickly, but again, I think most students for this one would probably want to do something on the side here, either using decomposition or hopefully some fast factoring, or whatever method you want to call it, the cross method or the box method, whatever fits. Now, when I mark questions like this, I don't want to see a whole bunch of factoring stuff here. If you want to do your factoring as a process, you do it on the side and then just move your answer here. When I'm marking questions like this in this unit, I'm not going to go and look at your factoring where you might have messed up or did you do everything correctly. All I care about, did you get the right factors? Okay, so that whole work that you do over here is for your benefit only. I'm not going to go back over here and mark. I might point out that, if you're close, maybe, that should have been a minus sign there or something like that. But again, if you can do this in your head like I just did, all the power to you. I'm not marking your steps. Okay. Now the bottom one is a little bit harder because the 4 is not a prime number, so I could have a 4y and a y. I definitely have a 3 and a 1, so I can start off with my 1 and my 3. That's definitely. And if I looked at 2 and 2y, 2y, I would have 6 and 2. 6 and a 2 won't get me a 13. So then I'm going to try a 4y and a y and see if that works. So that's a 12y, that's a 1y, and that can get me a negative 13 if they're both negative. So I found my two factors fairly quickly, and you can see that I do have a common factor. But before I do that, again, let's look at the restrictions. So I can see from the restriction that 4y minus 1 cannot be 0, and also y minus 3 can't be 0. And that this reduces to 4y cannot be 1, therefore y cannot be 1/4 or 0.25, and here y can't be 3. Okay, so there's my restriction work, which I'll add into my answer. Now, I want to give you a little hint here that might speed up your factoring process, especially for these complex trinomials. If you do your factoring for 1, there's a pretty high probability that one of those factors will also be a factor down here. So if you did the easier one, whichever one that happens to be, and you're thinking about what could go on the bottom here, I'm not saying to cheat because it's not really cheating, but you might look at one of these two factors and say, could I have a 2y plus 5 down here? No, because of the 3 there, right? But could I have a y minus 3? Yeah, I could, because that y minus 3 could work, and once you try it, test it out, it does work. So knowing what the other side factors are can actually help you speed up your, especially if you're doing the fast factoring method, which ones have a high probability of working based on what you've already done. Okay, so now when I look at these two, I see y minus 3 is common in both cases. So that can now reduce. I've just got these two factors left. So it's 2y plus 5 over 4y minus 1. And of course my restrictions, there's two of them, are x cannot be, I'll put them in order again, 1/4 or 3. Okay, so hopefully you get a good feeling for that, of the different, basically always factor first, then do your, once you factored everything you can, do your restriction work that we do on the side here, and then add it into the final answer. And then if you can cancel any factors, you do that after the restriction work, and then simplify it as much as you can. Remember, no brackets in the final version. And make sure your restrictions are stated. Okay, so that's it for this lesson. In the next few lessons, we're going to be looking first at, we're going to be multiplying and dividing rational expressions, and then finally we'll look at adding and subtracting. So obviously we'll still need to do some you'll still need to do some simplifying in all of those lessons. So this has to happen in the next few lessons as well. So it's a skill that you, even if I got a question that said add these two rational expressions, I still have to understand how to simplify my answer. Okay, for the homework for this, it's a separate handout sheet that is included in the folder for this lesson. So work on that. The solutions are posted there as well. So do your best. The more practice you get at this, the better you'll do. Okay, so we'll see you on the next lesson. Have a good day.